Well, we only have 2 days left to finish up all the fabrication stuff in the engine compartment of the F12. And then it's time to pull the engine back out and get it back over to D-Sport so they can finish the engine assembly. I saw some of the comments on the last video about the F12, and there were some comments that people were very concerned that there were metal shavings dropping inside of the engine through the intake ports. Don't worry, guys. It's okay, because there is nothing in the engine right now. It is literally an open block. There are no valves, no springs, no crank, no pistons, no rods, not even any sleeves. So the engine is going to come completely back apart. It's only held together right now by a few bolts holding the heads on, a couple bolts holding the oil pan on. So either way, it's not a big deal. That's why we have it back in the car right now, and trying to get all the fab work done before we send the engine off to finalize the build, because it doesn't matter if we get stuff in the engine. Later, when the engine is built, it definitely will matter. So every little bit of fab we can get done now, that's just gonna speed up the timeline. So we're really focusing on the engine, all of this stuff, the exhaust, the plumbing, finishing up everything there. And then when the engine's out of the car, we can go back to basically working on the chassis. And we have a bunch of stuff that we need to do to the chassis. One of the biggest things is to move the steering rack, because we have to move that down about 30 millimeters and about 65 millimeters further back to get the steering geometry correct. But that doesn't mean we haven't been working on the chassis stuff at all. We actually got some stuff done that I'll show you guys right now. In the back of the car, we have removed the fuel cell, also the radiator, and that was basically to make space so we could mount the Radium coolant catch tank up there. So this is going to feed into the top of the radiator. There's basically, there's ports on the bottom here, and we'll put a 90-degree fitting on here, and then it'll run over to the radiator and drop in there. So that's that's going to be the easiest way to fill the radiator, and actually that's going to fill the entire cooling system. So instead of having a coolant tank in the front next to the engine, we've moved everything to the rear. So the radiator's in the rear now, and the catch tank, or that's not really a catch tank, that's more of a coolant swirl pot. So it's also got a port on it at the top to where we can breathe the engine, because on the front of the engine, on basically every engine, there are coolant steam ports or vapor ports, and what they do is let the air bubbles out. So the water fills all the way up at the highest point, then they would have a port, and that is that guy right there. So,
that's what that is.
Yeah. So we've got the coolant lines that are basically cast into the front cover here on both sides, and that lets all of the little bubbles out of here. So then this is going to get routed all the way to the back of the car onto that one port inside of that coolant tank. So constantly letting any air that could be inside of the cooling system out to the highest point. We've also welded a fitting on top of the radiator to let the air bubbles out of the top of the radiator. So we got like a dash 4 welded right there, as high as I possibly could get it. So it's like right at the top of the radiator. This actually sits at the highest point. So that will let all the air out of there. And then this is where the water is going to be basically filled from. So the other part of the coolant tank on the bottom, we have that 90-degree dash 10 coming out. That's going to go right into that port. So we want to do as little as possible to the radiator. So when we get a spare radiator, because it's good to have spares of everything in a race car, when we get that spare radiator, we don't want to have to do a ton of work to modify it. So basically all we did was add that one dash 4 port, and then 4 pins on it to basically locate the radiator and hold it in place. But yeah, it's definitely coming along. We got all the coolant lines made for the main lines, the dash 20 ANs. So those are all done. And yeah, a few more little fittings in the back, that'll be good. But yeah, I'm just waiting on a couple fittings for the turbo water lines, and then I have to measure some turbo oil lines and have some made, because we'll use a different style. Instead of assembling the lines, we'll have a crimp style one built by a local hose place over here. So lots of little details you got to think about when you're building a car. And this is the time when it seems like the least amount is happening, but it's all the small stuff that has to get done, and it has to get done properly for the car to work right, and for it to be serviceable later, and for it to look good. So spending more time on the plumbing, we could do something really simple, grab some random fittings, put them around, but then it's just going to look kind of like cluttered. The lines aren't going to be routed as clean as possible, so everything takes time when you're trying to do it perfect. All right, so Tim's going to put these heat shields in that we made.
This is the original design. Before we had to make a little bit of modification.
Well, it wasn't original design. This is the heat shield, but we are going to cut it and weld a little box on the back to clear the sensor right there. Instead of making the heat shield shorter and not going and covering that sensor, we will just add a little box to it. So that way the sensor can be covered as well. Keep all that heat off of it, because obviously being just V12, you've got 6 crazy big headers on each side, the turbos, the X-pipe in the front. We are going to have to do some heat management, and that's what these heat shields are there for. So once these are done, they will get like that gold foil on the side where the turbo is and the exhaust is. So we will have gold foil all over on this side, and then this side will just stay aluminum. So the idea is that the gold foil here just reflects the heat off and keeps the valve cover, all the coil packs, the intake manifold, and everything cool. So we've got a heat shield that steps up where the turbo is.
Covers this whole downpipe.
Yep, and the turbine housing there. So that's all good, and then it drops down back here closer to where the headers are, where we didn't need as much. So same thing, just trying to keep it looking good. But right now I'm working on the other one and cut a section out of it, make a little cardboard template here. So I'll make this out of aluminum and then weld this up, and then also make a little front cap. I'll probably put some taper in this also, like grind this at an angle so it comes up at an angle rather than a straight 90-degree edge.
Yeah, it looks a lot nicer.
Yeah.
And I'm sure it definitely helps, because even on your drift car you had it and it definitely helped, but you were never really running it till your pipes were glowing really.
Well, they were, but in the middle of a run.
Yeah. But not like, I'm sure the pipes on this thing are going to glow for longer than 10 seconds, so it's definitely going to help with this.
Yeah, when we have the anti-lag going and just revving it, getting flame shooting out of the exhaust for, I don't know, a minute and a half at a time, maybe longer, gets a lot of heat, and there's no air movement, so you really need to worry about heat shields and just trying to deflect that heat so you don't get crazy heat soak on everything, especially the wiring and the electronics. If the intake did get hot, that's just going to rob some power. And in the tune, that'll all be adjusted for. We'll have an air temp sensor in the intake manifold. So when the air temps get high, it'll start to, it basically will compensate for the hot air, and we'll make sure that everything is safe. Obviously, there's gonna be a lot of fuel dumping in there to get the fire to shoot out of the hood and all that good stuff. But yeah, just lots of little details that you constantly have to think about when you're building a car like this. Another thing I saw in the comments was the hole centers. You guys are saying that I wasn't measuring correctly, and because I was measuring with calipers across the holes, I was getting the incorrect reading. Well, the fact is that the reading was off by like 0.1 millimeter or something. I don't remember exactly, but it was very, very small, and that plate I had welded was warped. So I think that the holes were not straight up and down anymore. They were slightly twisted, which threw off the readings a little bit. But after we did make that plate that went on top of the engine, it fit perfectly. The bolts went in, we didn't have any issues. But I'll show you guys what I was doing and explain it a little bit more so you guys can see exactly how to do it. It's actually very easy, and it's the best way to find the center of two holes when you have something like this. So this is another thing we're working on right now, is making these brake calipers that we got from Willwood fit onto the rear F12 uprights. We had to machine off the two old factory caliper mounting points over here. So they had these two nubs that were sticking out of there. we've cut those off completely so we can make room for the new caliper because there was interference as we're hitting. But to measure these, to make this template that I made that fits on there like that, we're obviously going to cut this out of thicker material. We're not going to use
this is just a mock-up,
aluminum. Yeah, this is just for mock-up. So instead of using cardboard, since we have a plasma table and I have the program, a CAD program, it's just easier to do it like this and make little changes, and then you get a template. So here is how you measure holes. So you get the holes. They have to be the same size. If this one was a 10 millimeter hole and this was a 5 millimeter hole,
it doesn't work?
This method wouldn't work. You'd
Okay.
have to do some more math there. But, so we've got this hole, and find the size of that hole. So I'm gonna go as big as I can. Now, they're pretty locked in. I'm gonna watch the numbers. It seems like about 9.9. That's what it is. We're gonna zero that out. Now, we've basically taken that hole and zeroed it out. So half the size of that hole is going to be subtracted on both sides basically by removing that value. So all the way across here, we have 133.3 millimeters. This is a Wilwood caliper, so I think it's definitely a standard number. And here we go. So it is 5.25 inches. It is 5¼ inches from hole center to hole center. If I close the calipers right now, I'm gonna get minus basically 3/8 of an inch because the hole sizes are 3/8 of an inch. So I've deducted that size. And if I wanna double check to make sure everything is good, I'll go back. Now these are zeroed, and I can measure from that edge to the inside edge here, and that's gonna be close. I'm getting 5.2470. It's really close, but it isn't as exact or accurate as when you subtract the hole size from the total number. Obviously, you could zero it out and measure all the way across there, and then write that number down, and then measure the hole, and then subtract this number from the larger number, and that would give you the same center to center. But the calipers have an easy zero. You can zero them out, and then you get those perfect hole centers every time, and you don't have to worry about it. So that is exactly,
that makes a lot more sense.
Yeah, so it's really easy once you know how to do it. But that's how we were able to get this to fit spot on. So that looks really good. This follows the contours and the shape of that really well. So when we get these cut out of 1/2 inch aluminum, we'll be able to sand this down a little bit more, put these on here. I'll make a little jig to hold this thing in place so it doesn't twist when we weld it. And then we will have F12 uprights that will bolt on our Wilwood calipers and our smaller rotors and all that. So lots of little details. All right, I've got these little boxes for the heat shield made up. I got that one tacked in place. I've got the little triangle piece just sitting on there. So I'll have to weld that up and then basically mirror this to the other side. I've already got the other piece cut and bent. Made these on the plasma table. It's quicker, it's easier than cutting them by hand, and it's also repeatable. So I had to make 2 of them, but also in the future, if we do have an issue and there's a problem with the heat shield, it breaks, it cracks, whatever, I have the file so I can just cut them out again on the plasma, bend the pieces and weld it rather than having to try to redesign the whole thing like if I was cutting it out by hand. Obviously that would take a lot longer. So absolutely love that plasma table. It is such a time saver when you're building custom stuff like this all day long. Well, while I'm working on those heat shields and welding them up, I don't have anything for Tim to do at the moment except for one thing, and that is something on my AMG. It's together, it's running, but I've got some issues. So one is the AC isn't working because it's not charged, so I got to charge it. That's not the only thing. I've also got no stereo, and when you drive an hour, 45 minutes to an hour each way every day in traffic, it's nice to have a stereo to be able to listen to some tunes. So I'm gonna pull the car in the shop right now and see if Tim can't figure it out. Might be a fuse, I don't know, but I've got no backup camera and no stereo, no Bluetooth, few issues. So, man, it is hot out here. It's like, I think it's about 90 degrees today, and I think tomorrow is supposed to be close to 100, and then the day after, close to 100. is brutal inside the shop. It's hot as hell inside my car. I should have parked it in the shade. Fire this thing up. And it's not that loud, it's stock exhaust, but it's fast. It is really fast, so, and that's still on the break-in tune. All right, let's pull this thing in the shop. And I also need to replace my key battery, and I've got a check engine light on. The check engine light is for a cam sensor or cam adjuster, so I'm gonna see if Steve's available at PTG to look at the live data and see if we can't figure out what's wrong with it. It could be like a bad cam sensor, it could be a bad cam adjuster. It's very similar actually to the newer BMW stuff, the Vano system. So the cam actuator sits in the front, and it's actually a magnetic thing that pushes and pulls on this valve, or twists, changes oil direction, and gets the cam to rotate to it'll either advance the cam more or retard the cam more depending on how much throttle you give, how much boost there is, where you are in the RPM range. So all of those parameters are in the ECU. But if that thing isn't working, the cam is just stuck in one position, and you're losing out a lot of drivability and possibly a lot of power depending on where it's stuck. If it's stuck in the right spot, you'll make all the power at the top end, but the bottom end won't be very good, or vice versa. So definitely need to sort that out too. All right, Tim.
Yeah.
So if you could look into this for me.
Yeah.
Start digging in the fuses.
I know one fuse box is in the trunk.
Okay,
and
well.
there's another one somewhere.
I will
I don't know where it is. I'm assuming under
pop
the
that
hood,
trunk.
maybe?
Yeah, that's something else that's weird. Like the car doesn't have a fuse diagram. I don't know if it was in the owner's manual, and I don't have that. But usually when you pull the cover off for where the fuses are on the back of that panel, it's printed out with each fuse and what it does. But this car doesn't have it for whatever reason.
Apparently they didn't come with it.
They didn't come with it.
Yeah.
So they just, from the factory, Mercedes was not worried about people knowing where their fuses were.
Yeah. You're not supposed to touch that.
Yeah, I'm guessing they just want you to take it to the dealer and let the dealer charge you for it. But we're not gonna do that. We're gonna fix it ourselves. So there is one fuse box in here. There might be one down there by the passenger footwell. And then you said there's another one in here?
Maybe. I don't know where the front one is. I only knew that I've seen the back one before.
I mean, there's a box here, like a power junction box, maybe.
Yeah, but the picture looks bigger than that.
Let's see. This looks like,
That's
yeah, that's just like a distribution block. All right, well, I will let you sort this out while I go back and weld this heat shield up for the F12. Heat shields are done. Got them all welded up, sanded. They are ready to be installed when we're gonna install them. No reason to put them on now, but yeah, they're ready. Let me check in on Tim, see how he's doing over here. How's it going, Tim?
finally got the panel off. So far, so good.
So you can find the fuses down there,
Yeah.
but now you just got to go through and probe them. And
Yeah, I'm just checking all of them first. So far, they're good, which is a good thing and a bad thing.
yeah,
The only one I couldn't get a reading on was this big 40 amp fuse, but maybe because these ones are a little bit harder to get these probes in.
yeah. So you're just doing an ohm check across the fuse.
Just for now, and
Yep.
then I'll go deeper if we can't find anything yet.
Yeah.
So we'll see.
Yeah, my fear is that that mouse, rat, whatever it was, that was in the car, ate something else that was important, and that's kind of wreaking havoc. So backup camera doesn't work. The display works. So that comes on, you can scroll through all the menus. You could turn the radio on, but there's no sound coming out. So at first I was thinking amplifier, but maybe it's not the amplifier, maybe it's something else. I don't know why that would be tied into the backup camera. Yeah, it's a bit of a mystery at this point, but starting from scratch, trying to figure it out, fuses are the best place to start because, well, if something failed, it should have failed by popping a fuse and not frying something else, but we'll see. So I got the intake manifold, well, part of the intake manifold off of the F12 right now. It looks
I found
sick, right?
something.
Oh, we got a blown fuse?
Oh, that doesn't help.
Yeah, but that's, let's see if we can focus in on that guy.
I don't know what circuit that is because it didn't have a number on it, but
This thing does not like to focus. But anyway, the fuse is blown, so you can see like inside there's a little wire. The smaller the number is on the fuse, like this is a 15, so it's kind of in the middle. A 7 amp or a 5 amp fuse would have a little tiny wire, and a 30 amp fuse would have a much bigger connection between the two posts. But yeah, it's broken. It's definitely blown. So yeah, I don't know what it's for. But
I don't either. But I can put another one in.
yeah, I mean that's probably a good bet. So hopefully that fixes it on the AMG, but we'll see. But anyway, back to the F12. So I got the intake manifold off it right now, so I can finish up the fuel lines and make sure all the plumbing down there is finalized and fits exactly how I want it to fit. But also, it's so cool to see the intake manifold with the top, with the plenum off of it. I'll show you guys right now, but you can see down the ports and see how nicely the intake manifold matches up with the exhaust or with the intake ports, and also with the injectors. It might be kind of hard to see in the video, but so we've got that. That's going to flow a lot of air. Then we've got the injector hole right there, and you can see the angle of the injector. So that's going in, and then the port in the head is nice and lined up. And like I said, it's hard to see, but the injector should spray right in between those two ports because it's a 4-valve motor, so 2 valves on the intake side on each cylinder and 2 valves on the exhaust side of each cylinder. Unlike, say, a Chevy LS, like a pushrod motor, or a lot of other engines, they'll only have 2 valves, 1 intake and 1 exhaust. And then you can get as crazy as having 5 valves, which I don't think a lot of cars have that. I've never built an engine on a car that has a 5-valve head, but I know a lot of motorcycles have it too. Yeah, it's pretty cool. But yeah, I'm gonna put all the lines on now and just make sure everything fits. See how it looks. There we go. Lines are on. They are obviously not fastened right now. I still need to make some little, maybe something that comes off of here, like an extension. So I could make something with a bolt on it that also has an extension that's threaded on top, so I can put a clamp on there to hold that line in place to keep it nice and straight and almost like hidden underneath the intake manifold between the valve cover. But what I want to do right now is basically just make sure the line lengths are all good, and also the clocking of the fitting so the lines aren't twisted at all. And it looks pretty good. So we've got our fuel coming in from here. So it goes down, that's not fastened yet, but way down there is a Y fitting that's actually going to be centered up and be mounted on probably on the inside of the transmission tunnel. So it'll be like on the bottom above the transmission. And that is the fuel in. So the fuel goes through the rails, and that feeds all the injectors, and then it comes out of each rail and goes into the fuel pressure regulator that is right there. Very, very tight, but there's a little bit of clearance, and that's all we need. And then out of the bottom of the regulator, another line that's not there yet, but it'll be a single line coming down, and that will return straight back to the fuel tank. We can get away with the fuel pressure regulator being about that far away from the fuel rails and the fittings and all that, because we have solid engine mounts. So we made solid engine mounts. They're made out of steel. They will not move. Same thing with the transmission. That's mounted solidly. So the engine and transmission will be basically fixed to the chassis. So there isn't any movement, any twist like you would get with a rubber or even with a polyurethane bushing. It would move a little bit. This won't move at all. So we can have really tight clearances on everything, and we don't have to worry about it making contact. And I don't mean tight like as in 0.5 millimeter. I mean, 4 or 5 millimeter, 10 millimeter gaps for pretty much everything, the exhaust, all the lines, all that stuff. So just enough clearance to keep everything happy, but also there really wasn't anywhere else to put the regulator that looked good. It would have been offset somewhere, and then it would have been off to the side, and then lines running, and then more lines running. You would have just seen everything, where right now it's all hidden, but also easy enough to work on. I've got some fittings and weld-on adapters and stuff coming that should be here tomorrow. So in the meantime, I'm trying to figure out where the best spot is to tap into here and here for the water for the turbo. So we've got the inlet, so basically water is going in to the water pump here, and then after it circulates around the engine, the hot water comes out here and goes to the radiator to get cooled down. So we need to get ports from the cool side and go to the turbos, and from the hot side and come out of the turbos and go back in, basically to go to the radiator and get cooled. I think you can put something on the bottom here, weld a -6 on here, and then use a T-fitting, so we'll have hoses coming out of either side, and kind of follow along here and go straight up there to the turbo. Same thing on this side, come out of here, go across, and then come up here and go around the steering shaft so we don't have any interference, and go up there to the turbo. And then the other lines will probably run and just run along with the turbo oil drain and then come down and go somewhere, but I'm trying to figure out where it needs to go and what's the easiest way to get there. There is a fitting on the side of the block that we haven't used yet, and it looks like a water line to me, and that is this tube right here. So I just kind of stuck it in there, and yeah, no bolt on there, but it's in there pretty good with an O-ring. But either way, it has a hose coming out of it, and it is cut over here. When we took the car apart, we didn't cut much. Really little, actually. So I'm not sure if we cut that line. Do you remember, Tim?
What line?
So we've got this I think water line on the block here. Maybe this was a heater hose. It wasn't an oil line. There's no oil in there.
No, that's a water line for sure.
You know what I think I'm gonna do? I'm gonna get some compressed air and like seal that part up and blow into it and see where it comes out. That's gonna be the easiest way to figure it out. I looked on tons of documents online to try to figure out the whole plumbing system on this car and where everything goes, but it's just lacking a lot of information. Can't really tell the water system. I could find like the radiator hoses, the thermostat, the water pump, but that fitting I can't find, and I can't find any of the lines for the heater hose either, actually like installed or in a drawing to figure out how it's all plumbed. So yeah, I need to figure out if that is a water line, which I think it is, and if it is it the hot side or the cold side of the water line? So I'm gonna hook up an air line to that right now and just blow in there and see what happens.
Can you blow it? Because since there's no sleeves, won't the air just go everywhere in the engine?
Yes, possibly, but it depends on where it is.
Yeah, because this might just be like a little part, like it has its own channel in the block.
Yeah, I mean, it does look like on the side of the block, you can kind of see that, you know, it's got all of these like cast, you know, passages in there. But yeah, I can't tell what's what. But yeah, now that you mention that, without the sleeves being in the engine, water passage is just open. Well, give it a shot anyway.
In other news,
See
I
what
checked Mercedes of Huntington Beach, and they said that to take the fuse out for the radio and let it sit for a couple minutes and plug it back in like a modem would for your Wi-Fi. That solves connectivity issues sometimes.
That's crazy, but all right, give it a shot. I mean, at this point, we've got nothing to lose. Take a fuse out.
Yeah, I checked every fuse.
Yeah. And it doesn't say like disconnect the battery. It just says just pull the fuse, huh?
Yeah, it says pull the fuse for the radio and audio system.
Very interesting. Maybe something needs power and that doesn't need power for it to reset. I don't know. Like I said, I don't really know factory electronics. That's not what I'm good at. I stick to the really Motec is what I know best. That's what I've used in like almost all of my builds because, well, it's just really high quality. It always works for race car stuff. Obviously, I'm not putting a Motec in my street car. That would not do us any good. We would lose tons of the features. And as far as like making power, because this ECU is tunable, we're not going to make any more power with an aftermarket ECU. I think that the guys at PTG have complete control over everything they want to do, and I know they've made over 1,500 horsepower with these engines with the factory ECU, so that's staying as it is. Just got to sort out the radio and the backup camera issue, and a couple other little like weird buggy things that could just be user error, because I don't know AMGs at all. The mute button is not on, so I can tell you that much. The stereo looks like it's coming on, but there's just no sound. Well, I got the blower on here, put some duct tape to
Seal it up.
Close that hole up, and let's see.
I hear it somewhere.
All right, well that worked. So I saw the passage and it looks like it does come up here.
Yeah.
But yeah, that confirms it, that one is connected to the water pump side.
So is that cold or hot?
That is that's where the cold water is coming in. So
Oh, okay.
It's sucking in from the front of the water pump here.
Yeah.
From the impeller, and then it's pumping right back to there and then through all the cylinders. So that's basically a passage out of the side of the block for the cold water. So that's perfect. So we'll get one of those. I'll have to weld a fitting on there.
Yeah.
To adapt it to an AN line, but that's good because there's not a lot of room on this housing for a fitting to go on. Here I can tap it. There's a lot of room, obviously, over here.
Yeah.
And the front pulley actually doesn't go past here, so it sticks out a bit, but it doesn't like cover any of this. So this is all open.
Yep.
But I still think that a T off the bottom is going to be the cleanest way to get that other water line routed.
Yeah.
But yeah, this is just kind of like all of the little stuff that you have to figure out on engines that you've never done before.
That no one really has done before.
Exactly. So we've got, water lines for turbos, because this thing didn't come with turbos. So we have to make all of these fittings and, figure out where to put them so that they actually work. Because if we tapped into two hot sides, water's not going to really flow through there. So you really need that differential between the hot and the cold sides on there. And obviously colder water is better for the turbos than hot water. So coming out of here might be 230 degrees, but in here it might only be 200 degrees or 180 degrees or whatever it might be after it goes through. So yeah, now I can figure out what fitting I need. I ordered a few random fittings too, just so I can get the plumbing done as quickly as possible, because fitting should be here tomorrow, and then the day after tomorrow we have to pull the engine out of the car to get it over to D-Sport. So not a lot of time left to figure out all these little things. I was able to find it after all, and after thinking about it some more, it looked like a water line. It is a water line, but what was it connected to? Well, it was the gearbox. So it was the gearbox cooling hose, and that's why it was so large. I was thinking, and it's really big for it to be a heater hose. It doesn't seem like it should be that size. Now it makes sense. It's actually the cooler for the gearbox. So the water lines run all the way to the back of the car to where the transaxle is, where they have the cooler on the side of the transmission. So it's a oil to water cooling system for that, a heat exchanger. And so it pumps the water all the way to the back, goes through the system, and then it goes back to the front. And we're missing a lot of the connections for the for the water system, because we removed a ton of it. It used to sit in the front, basically where the intercooler is now. So all of that stuff is gone, and it's sitting in a box over here. So this whole thing used to be on the front of the engine, connected to those water lines. So then we have, I think that's probably the return line for the gearbox cooler. So it would go through that other pipe that we looked at, come through there, go through the cooler, and then come back and dump back into here. And then this is the thermostat housing. And well, we're not gonna use the thermostat anymore. We're gonna ditch the thermostat, and we are gonna warm the car up It's going to take a little longer, but it's a race car. Thermostats, for one, it's just added complexity, but it's also a point of potential failure. It's not like thermostats fail often at all, but it's just one thing that if that thermostat stuck closed or didn't open enough, the car would overheat and you could seriously damage the engine, overheat the engine. So we get rid of that completely. And then we leave the factory water pump to help circulate the water. And we've got an electric pump now that we can have the ECU turn on and off. So basically, we've probably got about 5 to 6 gallons of coolant or water in the system. So it's a lot of water, and it takes a while to heat all that water up, but also takes a while for that water to be cooled down. But either way, so now we've got the electric pump that we can turn on at whatever temperature we want. Like we can let it get up to operating temperature, 170, 180 degrees, whatever we decide where we want it to come on. We can have the water pump come on. That'll help flow more water and cool the system down, and then stage it with the fans. So we can have like one fan turn on first, then the second fan, depending on how hot it gets, just to keep that water temperature exactly where we want it. For a couple reasons, right? You don't want the engine to run too cold, because then you don't get very good fuel efficiency. And that's not just for, you know, how many miles a gallon you're gonna get, but also to make the most power. So we'll probably want the engine to run right around 170 to 180, and we want the oil to be at least 210. And I know that sounds like, oh, can't you keep the oil cooler? You could, yes, but the oil doesn't really start working, especially synthetic oil, until it gets around 200 degrees or 210 degrees in that window. 230, 240, that's fine. 250 is where conventional oil starts to break down, but synthetic oil is perfectly fine there. If it gets to 300 degrees, you need to do an oil change because the oil has broken down, synthetic at least. But you want to keep that oil temp up because it helps. It's the proper lubricity for everything, but it also opens up, okay, I'm not going to say this exactly right, but basically what I was told by an oil engineer when I was working with some oil companies in Formula Drift, at the temperature at about 200 to 215 degrees in that range, the oil molecules will actually trap little particles and hold them and keep them from I don't know, rubbing against stuff and causing engine damage. Like I said, I'm not saying it exactly right, but I do know that you do need the oil to be up to temperature. So getting back to what I started talking about, water temp 180, oil temp 210. They always have about a 20 to 30 degree spread between water and oil temperature. Even if it's a heat exchanger, the water is going through it and the oil is going through it. The water drops it down, but the oil temp is always going to be higher than the water temp. At least it always should be higher than the water temp. We have some other cool stuff for the F12 that I haven't gotten a chance to show you guys yet. More stuff from Radium. So we've got the filler on here now. So it's a dry brake quick fill system. And we got these fuel tanks. Actually, these are pretty cool too.
What are those?
These are covers.
For the top
of the jug. So when you put the valve on there, I'll show you. The Radium stuff is always packaged so nice.
Yeah, they're very safe with their products.
Yeah, everything is like, yeah, really, really nice packaging. But let's get this thing out of here. Try not to scratch it. Alright, so we've got the quick fill that's basically goes right on top of the jug here. The jug is threaded, so that pops on there.
Oh, that's pretty cool.
Yeah, so I have the old version of this.
Where you slip it on, right?
Yeah, so you have to use like a hose clamp, but they changed up the style. They made their own jugs with that threaded fitting now.
Yeah.
So you can just unscrew it to fill the jug up and then screw it back in. They also have a new, like a breather system here. Instead of that plug that was in there,
Yeah.
that was like difficult to use.
Yep.
They changed that up too, so they have a vent cap.
Oh,
on
that's
here
cool.
now that has like a little screw top on it.
Yeah, so you don't have to
screw it on.
wiggle with it and
Yeah, and it's got
leak
that
out
normal,
and
yeah,
yep.
that flip cap thing, so you can flip it open. But basically when all this is connected, to fill the car, put the jug on here, put it on there, and just push down.
Now
like
it's
that.
open.
And it's open, and the fuel is flowing, and it's flowing fast. So this will pull back, and it's got an O-ring seal, and then this opens up, lets the fuel in. Same thing in here, this flap moves down, it's on springs. So it moves in and it lets the fuel flow around. So you can fill a 5-gallon jug in probably about 15 seconds. It'll go in really fast, but the other part of it is the air coming out. So we've got the vent tube here,
Yeah.
but it's small. It's only a dash 8, so it's not going to be the fastest fill. If we put it's called a discriminator valve,
Yeah.
and it's very big, and it has what looks like a ping pong ball in it. So when the fuel is going in, the ping pong valve ball will actually like move up and let tons of air out, and then as soon as you're done filling, it's in a little thing, and the ball will go up and seal the top.
Oh, like
So
once the fuel hits it.
Yeah, so when you fill up the tank, that ball stops the fuel from going out, and then it just stops flowing, and then it drops back down once you start driving. But that system is really, you'd only use it in like an endurance race car,
Yeah.
where you're coming in and you're trying to put 20 gallons in the car in like 15 seconds.
Yeah.
It's awesome if you're trying to do that. But for us, we're gonna run, the car has a 10-gallon tank, and by the time we burn off a set of tires, we'll probably have used about 3 gallons. So we should be able to fill the 3 gallons in about 15 seconds or so, pretty fast. But it's not like an endurance stop where every second counts, right? We're gonna jack the car up, we're gonna pull the wheels off of it, we're gonna put a new set of wheels on, torque the wheels, put 15 seconds of fuel in it, and then it'll be ready to go again. And in that time, the car has a chance to cool down a little bit, because things are gonna get hot. Making 1,500 horsepower out of that V12, it's gonna make a lot of heat,
true.
a lot of noise, and a lot of smoke. Here's that little cap guy, or little cover. So you can just pop that on there. Maybe it'd be easier if it was on the tank. There we go.
Well, it's pretty tight, so it's very snug.
Yeah, so we want to keep all the debris out of here. So if you're transporting the jugs, for one, if that gets dinged, it's going to leak when you try to fill it.
Oh, yeah.
Or if you get dirt around there, like you don't want dirt in your tank to begin with.
Yeah,
right?
exactly.
So yeah, these are pretty cool. Keep everything nice and tidy and clean. So when it's transporting, and at the same time, this isn't like banging against anything, because you got this nice little padded cover on it. So looks like we got nowhere with the diagnosing of this.
I reset your Wi-Fi, but it didn't work.
My Wi-Fi.
Yeah. You know how like when your internet doesn't work, they tell you to unplug your modem for like
Yep.
30 seconds?
Yep.
That's what I tried, but it didn't work.
It didn't work. All right. Well, I talked to Steve. So Steve's going to come down here from Premier Tuning Group in the next few days, probably, and bring his, I don't know, factory Mercedes tool or something. There's probably quite a few things that need to get just recoded, reset, adjusted, calibrated, like the cam sensor. It might not actually be a bad part. It might just need some adjustment in the coating, is basically what Steve was saying. So he's gonna head over in the next few days and help me out with that, try to get this thing all dialed in. And then, I talked to guys about the other taillights. Those should be here in a little while. The funny thing is, there are not a lot of GTs around on the streets. When we went to the dealership to find some parts, the guys were actually coming out of the dealership to see the car, because they were like, wow, we don't see these often. They're pretty rare. So I thought it was pretty cool. And driving around, I have not seen any others on my commute over the last few days. And this is LA, so I see exotic cars all the time. That's pretty cool. But we've got, like I said, those things that we need to dial into the car to get it working properly. And I have to coat out the wing, because the factory wing has like the little one that pops up like Cayman does, but this one's a fixed wing. So I keep getting that error message. And I'm also getting an error message for the battery, because we took the lithium ion battery out of the car and put in a regular battery, because one, I didn't want to wait however many, I think they said at least a month to get the battery. But it was also $1,900 for a battery, which is insane for a street car. If this is a race car and it was going to be like, all right, well, it's 20 pounds lighter, all right, spend the money and get it. But for a street car, especially because the battery wasn't even that light to begin with, I'm not sure why the lithium ion battery was so heavy, because there are some from some companies like Anti-Gravity that are literally like 6 or 7 or 8 pounds. and this one was like 40. So the lead acid one is somewhere around 50 pounds. But yeah, I'm getting that error code because this is not plugged in. So on the factory lithium ion battery, this plugs in and it's on the CAN system, and it's sending data to the onboard computer of how the battery is performing, I guess. And without that there, you get a code that comes on the dash. It's like, stop the car, go to the dealership, battery problem. Obviously it still runs fine, it just has that error. That's kind of annoying. So got to get that coded out too. Well, now that I know that I need this fitting, I'm going to take it over to the bandsaw and chop the tube off, and then I'll put it in the mill and mill the top of it down because it's got some, I don't know if it's exactly weld, it looks more of like a brazing. So I want to get all of that off so I can weld the new aluminum Dash 6 fitting onto that. I won't have the fittings till tomorrow, but something I can do now is just prep this one and get it ready. So I'm having a little bit of problem here because this has a radius on it, so it's not sitting perfectly flat on the vise. So I'm gonna grab a couple pieces of aluminum to use as shims to lift this up slightly, and then I can get a better grab on the piece. I've got to be careful too not to tighten it too much because I will damage this and it won't be round anymore. It could be slightly oval or have a flat spot in it. But yeah, I need to make sure it sits really flat and is snug enough to where I can run the cutter over it and machine some material off it without it trying to grab and jump out of there. And now we got it machined down. There's a lot of burrs on here because the tube on the inside is kind of flaking up, so I'll have to clean that up. We've got a nice flat surface now to weld our fitting onto. And if you guys are machinists and you're out there and you're looking at this roughing end mill and saying that that's not the right thing to use, I know. It's just what we have here. We've got very, very, very few tools, and it's kind of like we only buy it when we really need it because we're only building one car, really, with all this equipment. So trying to keep overhead and costs down a bit by not just having this massive catalog of end mills and fly cutters and all the other stuff that we might use someday in the future. It'd be nice, but I don't know, getting it done without it, it's all good. It's still cut nice. Nice enough, anyway. This fitting is ready now, except that it's not clean. It's still a little bit dirty, a little bit oily, and I would use our ultrasonic cleaner, but it died, unfortunately, for whatever reason. It's a cheapo Amazon one, and I actually have the same one back at my shop, and it's worked for a long time, and I've cleaned tons and tons of parts with it, but for some reason this one failed pretty quickly because we really haven't even used it that much. But for whatever reason it's broken. We still got to clean this part, so brake cleaner and a wire brush, whatever we need to do to get it done. Tim is currently putting the front links onto the lower control arms. So these are the ones that have the that are solid, basically, so there is no pivot in here. That will keep the arm from rotating because, like I said, the shock is slightly off center, and it's going to load the control arm and try to push it down and up. And I had to do that to get the shock in the right spot for the upper control arm. So this kind of solved that problem, but still allows us to use this to adjust the caster. So we can make this longer, make this shorter. I'll try to get a better view so you can see what's going on. But yeah, this is moving forward and backward. So we'll have like really quick and easy adjustment to move the wheels slightly forward on the bottom or slightly back, which changes the caster. That will also affect a few other things as well. So we'll adjust that, and then we'll have to check toe again because the tie rods will get slightly longer or shorter as you adjust it. Could change camber slightly also, which we could adjust. But when you're trying to do a quick test and you want to add a degree of caster or something, we can check it out. And we can also go in and make a bunch of notes before we go to the track or whatever. So we can go, all right, 1 turn equals point whatever degree of caster change. So we know where we're at, we have our settings, and we go, okay, let's go 2 turns forward to get another 1/2 degree of caster, and then we can just write our notes down. We don't have to get the alignment tools out for every single change that we make to the car to try to get it dialed in faster, or to get it dialed in for different tracks or whatever driving situations we're trying to do with the car. So we're kind of a stopping point right now as far as all the stuff on the engine goes, all the plumbing, until we get our fittings tomorrow. So to not waste time, there's a couple of things I need to do, and one of those things is to finish these intercooler pipes. So we have the intercooler side done, and we've already got a bead rolled on it. So we've got a bead rolled on there. They're all cut and finished. And these were actually just one piece with this. So I marked these and cut them. So we only took about, probably about 1 millimeter or 1.5 millimeters out of it, but basically the width of the blade. So these are still a bit long. So I'm gonna cut off another 5 millimeters or so to give it a little bit of wiggle room to make it come out of the car easier. I do want to keep that gap down though, because the bigger gap you have, the farther apart your hose clamps are going to have to be on the beads, which means the silicone hose has more area for the air to basically pressurize, and possible for it to get a leak. So keeping that tighter is just going to be, well, won't give it any wiggle room really where it doesn't need to have wiggle room. So, and like I said, the engine's on solid mount, so I don't have to worry about it moving. So we can run a straight hose. Clamps are really close together. But to finish these, I'm gonna cut off that 5 millimeter and then put this in my bead roller and get that bead. So right now it's completely smooth where the hose could slip off. Even though in this situation it really can't, because this is here, this is on the engine, locked in place onto the throttle body with O-rings. So this only has a couple degrees of wiggle room in and out, and a little bit of twist, and that's it. So the only reason we really need to put a bead roll in it is actually strengthens the end of the tube also, so we can clamp those or put the clamps down tighter and not worry about it distorting the tube and kind of doing a flat spot or ovaling it or whatever. And it's just proper, right? Put a bead roll on it because we can, because it should have one. So I'll chop this and then yeah, I'll show you guys how the bead roller works. It's actually really cool. I love this chop saw. It is so good with a metal blade in it rather than an abrasive blade. It cuts like everything really well, especially with the Diablo blades. They are by far the best. But the one thing that isn't good about this thing is it is loud.
It's so loud.
It's like ear piercing, like shriekingly loud. Speaking of that, Tim, let me give you some earmuffs. Since you're holding the camera.
Oh, there's one there.
There you go.
Cool.
Put those on. I'm gonna put mine on. the DA, kind of flatten that out and get those burrs off of there. All right, well now I can use the deburring tool and get that out of the inside and finish that up. So these things are awesome and they're really cheap. So if you're doing any type of metal fabrication, these are really handy to have. It's like, I don't know, $5 or $10 or something. So pretty inexpensive, but it's just like a little knife and you just slide it around there. You get those little curls off, but now it's nice and smooth in there. No sharp edges and no debris that might go into the engine. And obviously when we're done, before we put the engine together, all of these things are gonna get cleaned. So every single hose, line, tube, whatever it is gonna get cleaned thoroughly before we start the engine up. So don't worry guys, we're being careful. I know that some of you guys were concerned in the comments about our lack of giving an F, but we do, actually, we do care. We want this to be done properly and run for a very long time. All right, so with this guy, and there's a bunch of different dies for this. This is for rolling beads and tubes. And then I have a bunch of dies down there, or not a bunch, but a few dies down there to do different things like roll a step in sheet metal. So like if you put these dies on there, you can get that little step roll.
Ah, I see.
I've got a bigger bead roll here that I haven't used yet. And then these guys, which are pretty cool, but they roll the edge. So yeah, when you make a flat panel thing, you want to roll that edge on it. These are perfect for that. So we'll get this set up in here. Get this thing clamped down. And then you got to start it out with a little bit of pressure and kind of get that bead forming.
Yeah.
If you crank it down a bunch and kind of like force the bead into it in that spot, it's always going to look a little odd, and it'll actually make the tubing not round anymore. It'll have like a flat spot in it. So we'll start out with a little bit of pressure. So we've got the pedal here to control it. And basically I'll just eyeball this because it moves. And you got to make sure it's centered up, obviously, so you don't get that bead to be crooked. And you don't want to push it up against this stop because the stop is two pieces, and where the edges are, it'll catch on the aluminum and kind of like grab the end of it and bend the tube. So I want to avoid that as well. So you can just barely see the outline starting to show up. And then I'll just add some more pressure to it as we go around. And that's looking pretty good there. So just go around a bit more and make sure that it is even all the way around. Looks good. Take the pressure off of it. And now we have a bead rolled tube. So I will repeat this on the other one. And then other than cleaning, these things are ready to go. We made some good progress today. Like I said, we're at the point where everything takes a long time to get little things done just because of where we are in the process. We do the big fab stuff. It comes together really fast, but all of the little details just take a lot of time. But we are getting close to the finish line. So in about 30 to 45 days, I really think that we will have the car running and ready to go to the dyno. So everything's kind of coming together now. The wire harness is almost done, but the guy who does the harnesses is in Arizona, and he's not going to come down here to finish the harness until we get the engine back in the car and we have all the other components. So right now it's just ordering stuff, talking to the tuner, making sure everybody's on the same page. Here's all of the wiring and here's all the inputs, outputs. that plug into the ECU. Here's where they go. Here's what pins they connect to. Here's the size injectors we're gonna run. Here's how many amps each fuel pump draws. There's so many things that have to get programmed in. You're starting from scratch. So you're basically telling it, here's the crank sensor. These are the readings from the crank sensor. These are how many teeth there are on the flywheel. Same thing with the cam. So all of those things have to be put in for this to work properly. And that's not even talking about the tuning side of things, of how much fuel, how long the duration of the spray of the injectors go, throttle body, parameters. There's so much. Coil dwell times. Man, it's a lot. But when we get to that point, we'll show you all of that, because it is really interesting. And I find it really interesting, at least. Starting from complete scratch, building this engine up, building all of this stuff, and getting the car to run. Big project, but we're making big progress. We'll see you guys soon.